Hi guys, the casual analyst here. On today's video, we will continue analyzing our e-commerce data. This is the second part of this series, so if you haven't seen the first one, you should go check it out through the link in the comment below to make sure that we're on the same page. There are many questions that we hope to answer today, which includes which products are frequently bought together, or which channels did the least usually come from, or which months have the highest demand. Hope you enjoy it. Okay, so the next task that we want to perform is, let's say, we want to know the product that are frequently bought together. So let me just importing and loading the data. How do we know the products that are frequently bought together? Well, we define the products that are bought together frequently when they appear in the same item list frequently, right? So it just means that we will get all the item list from all the order and count the number of times each combination of products appear together, and we will just simply merging the item data frame with the order data frame on the order ID, and then we will get the item list from each order, right? So let's now merging the data frame and explore it. First of all, we will merge the order data with the item data on the order ID, and let's call this one product frequency table. Let's run this one, print it. The two columns that we care about is actually only the order ID and the product ID column. Let's update it. Now, how do we get the list of the items for each order? What we can do is that we can iterate through each order, and on each iteration we will get all the product ID associated with that order ID, and that is the list of items, and we can get all of these lists of items and put it in a bigger list that we can use that on later task. Now let's just do it right now. We have to group by the order ID. So by doing this, we will only get the unique value for the order ID column. And the result of this function right here, there are two output for this function. First of all is the order ID group, and the second is the remaining data frame, which is all of the order columns beside the order ID one. And we will use the remaining data frame to get the list of product. Now let's do it. So for the order and the remaining data frame, in this we will get the remaining, we will get the list of product from the remaining data frame. And let's say we want to get all of these list of items into a bigger list. Let's call this one a list of item list. And for each order, we will update the list of item list. We will update it. Okay, now let's run it, and we will print out the result. As you can see, we need some adjustment for this line of code. First of all, we only get the value, not all the information. Now let's print it again, and it will not probably work. It will look really bad, but let's just print it out and I will show you how to deal with it. So the data structure for this one is the array. So the last adjustment is that we just make it a list, and now we have the final result. Okay, let's see the length of it. Roughly 100,000 observation, and that is the list of item. So what do we want to do now? Now let's iterate through each item list, and on each item list we will get all the combination of products, and later on we will count how many times each combination of product appear in the dataset, and that right there will indicate to it that which products are frequently bought together. So let's now break it down a little bit. What we want to do is that first of all, because in the list of item list, there's a lot of order that only contain one product, and those order doesn't help us understand or doesn't help us to answer this question. We are trying to know that which product are frequently bought together, which means that on each order there must be at least 2 items. So let's just get rid of the order that only have 1 item. Like, let's update the list, and let's say for the item, for the list of item in the list of item list, if the length of the list of item is more than 1, then we would take it. Meaning that if the length of the list of item is 1 or less than 1, then we will not get it. Let's perform this, and now we will print out the result. As you can see, every order has the length of at least 2. We can check the number of observation of this list is about 10,000 observation. But there is one more thing that I want to show you. So as you can see right now, although that we want to get rid of all the order that only have 1 item per order, we still have a lot of order that containing more than 1 item. But when we look more closely, this is just one product but is purchased many times, and this is not what we want to work with. We only want to work with a unique product ID from each order. So how do we deal with this one? What we can do is that we can drop the duplicate of the product ID per order. So it means that on this order there are 3 items, but it's just actually a 1 unique product ID. We want to get rid of all the duplicates of this only 1 product ID. So let's drop the duplicate with a subset equal to the product ID. And it will drop this thing. We only get the unique product ID of each order. Now let's run it again. Okay, so now when we print it out, there is probably no observation that containing duplicates of product ID. We can check the length of this one, other 3,000. So what is the next thing that we want to do? Well, now we can iterate through each item list, and we can get every combination of the products, and we will count the number of times each combination appears in the data frame. You can use this function from the iterating tools. It's the function combination, and I will show you how it works. So let's say for example this one. We will take the combination of every product. The combination function need 2 arguments. First of all is the list, and second of all is the number of values that you want to get. So let's say you want to see the times that 2 products appear on the same list, then we just use 2, and we can print out the value of this one for com in print out a com. It will be a tuple containing 2 values, which are the product that appear together in the same list of item. And now we can use this combination function, iterating to each item list and get the combination. Okay, so for the list of item in the list of item list, we will get the combination of that list 2, because we want 2 values to be examined, and this one will give us the tuples containing 2 products that appear on the same item list. Okay, so when we have all the combination, how do we count the number of time each combination appear? One way we can do it is that we will create a combination dictionary. We can use this data structure for this type problem, and for each combination, as a result of the function, we will search in the combination dict. If the combination as the result of this one is in the combination dictionary, then we just incrementing the value associated with this combination by 1. That's how we count the number of times each combination appear. Else, if the combination is not in the combination dictionary, then we will set a new key in the dictionary and assign it to 1, which is the first observation. And I believe this is how we can get the count of each combination. Let's print it out. Okay, very fast. So now let's just turn this to a series and turn it to a data frame. We can reset the index, rename it, this one will be the item 1. I am just making our result more readable and interpretable by transforming it to data frame data structure and reset the column name so we can interpret it more easily. This one will be the item 2, and the column 0 will be the count. This will be the res df. And let's say we are only interested in the first 10 combination that has the mod count. Then first of all, we have to sort the value based on the count column and set the ascending to false so we can see the highest count first, and we will get only the 10, or let's say the 20 combination. And let's call this one top 20. Let's see the top 20. Okay. No, I think we only need 10 of them. Top 10. Okay, let's look better. Okay, and that's it. Now we have the products that are frequently bought together, and this is the top 10 combination that are mostly purchased from our user. So let's move on to the next question. And this question is going to be very easy. We just wanted to visualize something. Now let's just visualize the distribution of the origin column. And this column right here, it contains the channels through which the lead come from. Let's just print it out so you can see it. It's from the seller dataset. Let's print the, it's from the MQL dataset. And let's print the origin column. Or maybe just show the full data frame. MQL stands for marketing qualified lead. Marketing qualified leads. And this data frame contains all the leads that have contacted to our sales representative, but the deals haven't been closed yet. And if you're not understanding what I'm talking about, it's probably because you haven't read the data card of this data set to understand the concept behind the business of this company. Is an e-commerce, and the data frame seller and the marketing qualified lead is dedicated to leads, and or you can say the sellers. And right now we want to know that from which channel did the leads come from, right? Let's say from which channel did the leads come from, and the result should be in a percentage form. It means that how many percentage of the lead come from social, from organic search, from email. Let's just print out the value count of this column. Okay, and we want to visualize it. Now let's just visualize it a little bit. Let's call this one data, and we will work with this data. To visualize, you first have to import the matplotlib. If you haven't imported it, then you should do it right now. You create a figure and an axis using the blt.subplot, and then now we want to visualize a bar, a horizontal bar with the y equal to data dot index, and the width is data dot values. Let's show this one. Let's see that we want to show the data on the figure. We want to show the value of each index on the figure, because right now you can see that, yeah, the organic search is higher than the base search, but like, what the exact number of these things? So how can we do it? First of all, we can use the x.annotate function. It requires two arguments. First, it is text that we want to put on the figure, on the axis, and the second one is the position. So because we have many index and each of them have a unique text and a unique position, we must iterate through every value of this index, retrieving its index and value, and then update and then annotate the result on the figure. Now let's do that. For the index and the value in the data.items, this function right here will get us the index and the value of this series, right? And the text, the thing that we want to show on the figure is the number of time, each channel appear on the dataset, or is the count. So let's just use the value to show on the figure, and the position is the x and y combination. The x is the count and the y is the channel. So let's just put in here is the count and the y is the channel, is the index. Okay, now let's show it. Let's adjust the vertical alignment to center so it looks better. Okay. One more thing is that you can see there's the top side and the right side line of this figure, and that will make our viewers distracted. It is unnecessary. So if you want to get rid of that, there's two ways that you can do it. First one is that you can use the function despine from the seaborn library, or you have to import the seaborn. Okay. Usually when we visualizing the data, we will have to import both the matplot and the seaborn library. So let's do that here as an S. Okay, now SNS.despine. There's no S. When I run this, there will be no line at the top and the right side. Okay, that's what we wanted. The other way that we can do is that, and this one is more flexible but takes more time, is that we can call the spine objects from the axis that we're working on and define exactly which spine that you are talking about. For let's say, for example, I want to also get rid of the spine at the bottom of the axis. So I can define it. You have the top, okay, the bottom, the right, and the left. So let's just get rid of the bottom. When you have called it, you will use the function set visible and set it to false. It means that we are setting it into invisible. Now when we run this, there's no spine at the bottom, but there is the spine at the top and the left, top and the right. So when you change to this method, you will have to do the same thing with all the spine that you want to get rid of. Therefore, also we have to use a for loop for the spine. For spine in, let's say what we want to get rid of, the top, the right, and the bottom. We will set the spine of this one to visible. And when we run this, we will get what we wanted. Okay, nice and clean. Now, if we want to also get rid of the number in the x-axis, we can use this function x dot set x take label to this one. It means empty, and when we run this one, there's no label. Okay, and let's set the x dot set x ticks again to none, and we have get rid of everything that is necessary. The final thing is that we want a title. Let's say exit set title. Let's call this one, I don't know, you can name it anything you want. Channel distribution, I don't know. Okay, now that is the first task. We want to visualize something. And what if we want to make a table not containing the count but the percentage of the channels? Then how do we do so? Again, let's just print out the data. Now if we want to make a percentage table, we don't want to outputting a series like this. We want to use the data frame data structure. So what we want to do is that we will use the group by function. We group by the origin, and we will take the count of each origin. We can count any column. Let's see what column this data frame have. Okay, MQLID. Let's count it. Reset index. Even sorted. Sort value by the MQL.id, and send in, set it to false. Okay, let's call one data. It doesn't matter what we call. Now, to get the percentage, we basically just, first of all, we have to get this column and apply a function to it. And this function, we can use the lambda. Okay, so for each x, what we want to do is that we will get each value and divide it by the sum of this column. Okay, let's just get the value, divide by the sum of this column. Okay, get the x, divide by the sum of the column, and we will have the percentage. Now let's see. Okay, so now we have the data, but let's make it look cleaner. The way we can do that is we can add in the percentage sign, but to do this function, we have to transfer it to convert this one to string data type. Run it. Okay, too much. We only need the first 5 integer, first 5 digit. Oh, we have to multiply this by 100. Okay, now we have it. Let's call this one percentage. Get the data. And now we have the column percentage, and this is the data frame showing the channels and the number of times it appears and the percentage of each column. Okay, so now let's move on to the next task. In this task, we will try to label every order that appear in the dataset as positive or negative, and we will try to find out which product usually appear in the order that has a positive review and which product usually appear in the orders that have negative reviews. The reason why we do this is that, well, maybe there are some products that when customer purchased, they don't feel satisfied with that product. And if we can get this information, we can quickly find and adjust the properties and the features of that product. And the same thing apply to many other aspects, not just the product itself. We can use that to find the product category that usually appear in the negative or the positive order, or we can use that to find the seller. Okay, so now how do we do it? First of all, we will use the review diaphragm. It has the column review score, and well, if the review score is more than 3, then we can say that it is a positive order, and if the review is less than 3 score, then it's a negative order, and if the review score is equal to 3, then it's just a neutral order. That is how we label the satisfaction of the customer. We also have to merge this review data with the order data based on the order ID. The reason why we have to do that is because after we merging these two diaphragms together, we will merge it with the last diaphragm, which is the item diaphragm, to get the product ID, because what we are looking at is the product that usually appear in the negatively or the positively reviewed order. So now let's merging these 3 diaphragms together. Merging 3 diaphragms together. We will merge the review diaphragm with the order diaphragm on the order ID, and then we will merge it again with the item diaphragm on order ID. Let's call this one satisfaction, status table. The next thing that we want to do is we want to label customer review. We will want to apply a function, a lambda function, on the review score column, and if the value is less than 3, then we will assign it with a name of negative order. Else, if the value is higher than 3, which is the review score is higher than 3, then it will be a positive order. Else, it's just a neutral order, right? Now let's print it out. If, okay. Let's name this table, let's name this column satisfaction. And let's check the distribution of this one value count. Okay, it's quite skewed to the positive side, but it's okay. So now we will group by the product and the review or the satisfaction column to get the count. Get the count of occurrence, which will outputting the value that we are interested in, which is the number of time that a product appear in a positively or negatively reviewed order. Now, status table, we group by the product and the satisfaction, and we get the count of anything. The count of, let's just say, is the order ID, product, okay, product ID, and satisfaction. Now, next, let's say we want to get top 10 product, top 10 positive products, and top 10 active products. Let's say top 10 pos will equal to, let's get the status table where the column satisfaction is equal to positive, and we get the first 10 of them. We get the first 10 of them to get a top 10, and this is it. Again, we will do the same with the negative products. It will be equal to negative order, and let's print it out. Okay, so that is the end of this task. Now we find out the product ID that usually appear in the positively or negatively revealed order, and based on this information we can later on adjust relevant information related to the product to increase the satisfaction of our customer, right? Okay, so this will be the final task of our tutorial. In this task, we will examine the seasonality of this business. We want to find out that is there a particular month that the demand rocket when compared to other month or not. So let's say the task is check for the seasonality. And we will do this using the order data frame with the column order printed timestamp. Right. First of all, we will get the month. Right. We will get the month of this column, of this one. When we get the month, we will merge it with the payment data frame. The reason why we want to merge with the payment data frame is because we want to take the payment value column to see the total demand, right? Because the payment data frame, it stores all the value of each order, and when we sum up the value based on the month, we will get the seasonality of our business. Let's start by changing this column to the daytime data type, just to make sure, right? So order, this column, we would change it to the daytime data type. Okay, now let's run it one to update the data. And now, the way that we get the month out of this timestamp is to use this function. And in this function, we can specify the format of the time that we want to get. Now there's a lot of way that you can change the format of the datetime. You can search for Python string time cheat, and because we are interested in getting the month, so we will use the M character. Now let's see. Okay, this is the month, and let's name this column month. Now we will merge this data frame with the payment data frame. Order merge with payment on the order ID, right? And this one is seasonality table. Okay, so now when we get the data that we need, we will group by the month and sum up the purchase value, the payment value column to get the total value of a month. Group by month, get some payment value. Okay, group by the month column and get the sum of the payment value column, and this one will be our interested data. Okay, so now we have the data. Let's just reset the index. We want to visualize the data a little bit. Let's visualize the data. Create figure in X, and we will use the plot function. with the x-axis being the month and the y-axis being the payment value. The y-axis will be the month, the x-axis will be the month, and the y-axis will be the payment value. Now let's see. We can set the theme to make it look better. The style will be, I don't know, let's just try it, dark. Okay, now to get more information, we can actually plot an average line across the month of the year. We can do that simply by plotting again with the x-axis being the month, just the month, but the y-axis will be a constant value, and that constant value is the average of the payment value column. Right? We would get the mean of it, and when I run this will not work because the shape of the x is 12. The shape of the y, the current y, is only 1, so we have to multiply it by 12. You have to turn this one into a list, and then you multiply it by 12 to get 12 value of the mean of payment value column. Now it will work. Okay, and that is all the tasks and problems that we have to solve in this tutorial. Congratulations, and I hope you enjoyed.